Alright, so today's lesson 5.2, which is Arithmetic Series. So, let's zoom in here. So the sum of the terms of an arithmetic sequence, for example, if we take the arithmetic sequence 3, 6, 9, 12, 15, and we add up those terms, that's what we call an arithmetic series. So basically every arithmetic sequence can be transformed into a series by simply adding all those terms together. And in this case, you want to find the actual sum of this arithmetic series. So we would just add up the numbers. So 3 plus 6 is 9, 9 plus 9 is 18, 18 plus 12 is 30, and 30 plus 15 is 45. So it's the sum of the terms. So now we're going to talk about the difference between a finite series and an infinite series. So in this class, we're only going to recognize infinite series kind of at a basic level. We're not going to really be calculating any or doing anything too intense with them. But if you do go into calculus, especially Calc 2, you will do infinite series. So, it does come up in other math classes, but we're going to basically be focusing on mostly finite series. So, the difference between a finite and an infinite series is a finite series has a certain set of numbers, and that's it, okay? So, look at the example 2, 5, 8, 11, 14, and then it stops. So that's what we call finite. Now, what do you notice is different about the infinite one? What does it have at the end? The dot, dot, dot. So in math, when you see this 3 little dot, dot, dots, that means that it just keeps going forever, okay? And if you see the dot, dot, dots and then a terminal number at the end, that means that we're talking about whatever the pattern is just keeps going in the middle there. So that's what that means in math when you see that in context. And in this case, you guys remember from yesterday or the day before yesterday, the D value, the common difference with a sequence? It's the same idea for a series. So what would be the common difference in this particular series? 3. Yeah, so you still find your common difference, okay? That's still the same idea. So now let's look at the rules of the sum of finite sequences. So obviously, if I ask you to find the sum of the first 60 terms of a series, okay, you're not going to want to calculate that by hand, so we have a formula for that. And we actually have 2 versions of the formula. The first version of the formula is useful if you know what the first term of the series is, or the sequence is, and the second term of the sequence. The first term and the last term of the sequence. First term and the last term. Now, when you don't know the last term, you'll need to know the first term and the common difference, and then you can use this formula. So we're going to be working through using these 2 formulas later on in the lesson, but those are the 2 formulas I'll be referencing. For example, 1 and 2, by the way, just so you know. So let's go ahead and now talk about summation notation. So this is probably new to you guys. This is what we call summation notation, okay? And I want to talk about it because you may have not seen this symbol before. Maybe in passing you've seen it in you've seen it in like movies or something where they're doing like hard math or something, and you see this symbol come up. You guys know what I'm talking about? You'll see that symbol. So now you're going to learn about what it is. So this is actually the Greek letter epsilon, capitalized, okay? So we start using Greek letters in math because we kind of use up all the English letters, so we start using Greek letters. And what this means is it's called a summation, which indicates that you're going to be calculating whatever this is here, and you're going to be, when you calculate it, you're going to be repetitively doing it and adding up all the terms, okay? That's what this symbol tells me to do. It's telling me add it up, okay? So I do want to mention a sub I is usually just a sub n, and it looks like this. A sub n is equal to, so you definitely want to write this down, a sub 1 plus d times n minus 1. That's going to be what goes in that spot of the formula. Now that you see this, does this formula look familiar to you? Yeah, where have you seen it before? Yeah, it's the same formula we use for explicit sequence, right? So because sequences and series are related, a sequence or a series is simply a sequence but all the terms added up. So we just calculate the term of the sequence and add it up to the next term. So that's basically what the summation tells you. Now there's two other important pieces of information you need to know about a summation. The number at the bottom tells you what term to start with, okay? So in this case we're starting with term 1. And this number at the top tells you your limit to where to stop. So if they go from 1 to 6, you're going to calculate 1, 2, 3, 4, 5, 6. If it says to go from 4 to 8, you're going to go 4, 5, 6, 7, 8. So this is like your lower limit and your upper limit. Okay, and you calculate everything in the middle. So now let's talk about looking at this example so we can see how you actually calculate using one of these. All right. So in this case, we have our rule, okay, and we're calculating it as a summation. So the first thing you're going to do is you're going to look at what you're starting at. What are you plugging in for n first? 1. So you're going to plug in 1 for n and calculate the simple expression. So 3 times 1 minus 2 is 1. You guys see that? So what number comes chronologically after 1? 2. So then you're going to be plugging in 2 in for n. So 2 times 3 minus 2 is 4. That's where the 4 comes from. And you're going to, every term that you calculate, you're going to add it to the next one. So you're going to add them all up. Now what comes after 2? 3. We do the same thing with 3. Calculate it. Add it to 4. We're going to plug 4 in. Plug in 4. And then lastly, I plug in 5. Add that up too. Now why did we stop after 5? Yeah, because it tells us right here, 5 is the last one you're going to do. So you're going to do from 1 to 5. So 1, 2, 3, 4, 5. Add them up, get the answer, and stop there. So you always have to look at your limits on your summation, okay? So that's how you calculate using a summation. All right. So this question says express 3 plus 6 plus 9 plus 12 plus 15 plus 18 using summation notation. So just like with a sequence, the first thing you always want to identify is your first term and your d value. So what would be my first term in this series? Good. So my first term, a1, is 3. And then you also want to find your d value, your common difference. So what's my common difference here? Good, we're adding 3 each time, so a positive 3. So once you've identified that information, you're then going to use the explicit sequence formula that we've been working with, which is a sub n is equal to a1 plus d. I was going to write d, we want 3. Plus d times n minus 1. So you plug into the formula you use for sequences. We haven't done anything different today than we've been doing. And now what you're going to do is simplify this. So I'm going to simplify this by distributing the 3. That's going to give me 3 plus 3n minus 3. And what do you notice happens to the 3's? Good, they cancel out, leaving us with a sub n is equal to 3n. So we're going to use that in a second. We're going to hold on to that. We're going to use it. So now we're going to set up our summation. So are we starting at the first term here? They didn't tell us otherwise. So if they don't tell you to start at the 5th term or anything like that, if they don't state otherwise, you're going to assume to start at the first term, unless otherwise stated. And then how many terms are there that we're going to be calculating here? 6 terms, so you're going to go all the way to 6. And then what goes right here is whatever you calculated for an, which is 3n. So this is what we call summation notation. Now it didn't ask us to utilize summation notation, but I do want to mention how it works quickly here. So if I gave you this, you should now be able to produce it to give me this as well. You should be able to go back and forth. So, for example, I'm going to plug in 1 for n. 3 times 1 is 3. So you get 3 plus, what am I plugging in next for n? 2. 2 times 3 is? Yep. And then next we plug in 3. And then I would plug in 4. And then 5. And then 6. See how I'm producing the same thing we started with? So that's how the summation works. So it's a good idea to test your summation out and try to calculate some of the values to make sure you did it correctly. So does anybody have any questions about this notation? Alright, so we're going to move on to example 4. The examples are out of order, which you're going to notice. We just flipped it around. So let's look at example 4. Now, something important you got to look at here. They want you to express using summation notation, okay? The thing that could be a little bit tricky about this question is they give you an n value, okay? Now, if they wanted you to calculate what happens when you add up the first 20 terms, they would have said that explicitly. But this is just telling you, basically this is the upper limit of your summation. Okay, that's all that means. That's the upper limit of your summation. All right, so now we're going to move on. Just give me a sec. I was just checking something. So, first thing you're going to do is you're going to write your explicit sequence formula. So a sub n is equal to your first term plus d times n minus 1. So you're not going to plug in 20 for n here. You need n in order to write the notation, okay? Now you're going to distribute. You're going to get a sub n is equal to 2 plus 5n minus 5. And then what is the sum of 2 minus 5? Negative 3. So that's your a sub n. You're going to use that to write your summation. Now, as for your summation, they didn't mention, you know, start at n equals 4 or anything like that. So you're going to assume to start at n equals 1. And then what's going to go on the top here? 20. Because your n is going to 20. You're going to be using 20 terms. And then what goes right here is just your a sub n. And that's your final answer. And like I said, you can always test it out to make sure it works. So if we plugged in if we plugged in 1 for n, that would be 1 times 5, which is 5. 5 minus 3 is 2, which makes sense because that's your first term, right? And if we know the difference is 5, we know the next term should be 7. And that does work out as well. So you can always check your work just by using that kind of logic. Any questions on summation notation? Alright, so since we've covered that, we're now going to talk about finding the sum of a finite arithmetic sequence. Okay? So, on these questions, they're not asking for notation. When they ask for the sum of a finite arithmetic sequence, you're looking for your answer should be just a straight number, okay? Because they're asking you to add up a certain amount of terms, and that's going to come out to be a number. So, on this question it says the sum of the first 100 natural numbers. So, in order to do this question, you're going to need to know, we're going to be using the formulas under where it says rule on your notes. So those two formulas. Now we either need to know the first term and the last term, or the first term and the common difference. Well, I definitely don't know a common difference in this case, not right off the bat, but I do know what the set of natural numbers look like. So I don't know if you guys remember this back from, you probably learned about this at some point in your math career. But if you just Google it, like I can just show you some pictures of what happens. Natural numbers, what do you notice that natural numbers start at? 1. Natural numbers always start at 1, okay? So you can see the different sets of numbers. Natural numbers start at 1, okay? So that's a certain set of numbers start at 1. So what's my A1 value going to be? Good. My A sub 1, my first term is going to be 1. And that's because I know the natural number set starts at 1. Now, we want to find the sum of the first 100 natural numbers. So the last number I'm going to add up is going to be the 100th number, right? So we do know the last term in my sequence. The last term is the 100th term, so A sub 100 is the 100th term. And the 100th term of the natural number set, we do know what that is, right? It would just be 100. Because it's basically counting, like 1. Those are counting numbers. 1, 2, 3, 4, 5, 6, 7, so on. And the 100th term would be 100. Does that make sense to everybody how we know that? Okay. So now that we know the first term and the last term, we're going to use the first formula under that section of the notes. Because that one is useful when we know the first and the last term. That formula is S sub n is equal to n over 2 times A1 plus AN. So that's the general formula. And now we're going to be plugging into this formula. Now they want us to add up the first how many numbers? 100. So our n value here is also 100 because they want us to add up the first 100 numbers. So we're going to now just plug into the formula. So I know that my n value is 100. So this notation, when they have S sub a value, it's saying the sum of the first 100 terms. So if you want to write that, you can. Sum of first 100 terms. That's what that all means in the shorter way of writing it. So they're saying that's the sum of 100. Yes?
Do you have to do that, or can you just leave it?
You do not, yeah, you don't have to write that. That's just me trying to explain it to you. Yeah. So, sum of the first 100 terms is equal to 100, your n value, divided by 2, times your first term plus your last term. So all I did was I plugged in to the formula, okay? Everybody see that so far? Now that I've plugged into the formula, I just use algebra to simplify this. So it's going to be the sum of the first 100 terms is equal to 50, because 100 divided by 2 is 50, times 101, because the sum of 1 and 100. Well, 50 times 101 is actually 5,050. So your answer always comes out to be a number when you're finding the sum of whatever you're finding. So basically what this is saying is, if you take the first 100 natural numbers, 1 plus 2 plus 3 plus 4 plus 5 plus 6, all the way to 100, that sum will be 5,050. So does that make sense to everybody? Anybody have any questions about it? All right, let's move on to example 2. So in example 2, they give me a sequence, but I want to find the sum of the terms of that sequence, okay? So, sum of the first 15 terms. Now, you could keep going with this pattern of the sequence and do this, but it's going to take you quite a while to do this, right? So let's use the sum of arithmetic sequences formula. Now in this case, we know what the first term is, and what is the first term here? Good. And we don't know what the last term is. How do I know right off the bat that we don't know what the last term is? Yeah, the 3 dots. And it's asking about the 15th term, and we clearly only have the first 4. So we don't know the last term. And if we don't know the last term, we need to know what the d value is, which we can figure out. And what is the d value here? 3. Because every time 3 gets added here, it's a positive 3. So now that we have those two pieces of information, I'm going to use the second formula in that box, because that formula is useful when we know A1 and D, when we don't know the last term. So we're going to use this formula because this is the formula you use when you know the first term and D and you don't know the last term. now that we know this information, what do we know that n is equal to in this case? 15. Because they want us to add up, find the sum of the first 15 terms. So now that I know all of that information, I'm going to plug into the formula. So the sum of the first 15 terms is equal to 15 divided by 2 times 2 times 2 plus 3 times n minus 1. So I just plugged in the information that I had. Oh wait, I forgot to plug in the n again. You gotta plug in the n one more time. Whenever I change colors around to make it more clear, I always forget to plug something in. Yep, last thing we gotta plug in is the other n. So look through it, make sure you understand where everything came from. Make sense? Okay, so this is actually an infinite sequence, but we're not using it infinitely, we're just finding the sum of the first 15 terms. So let's go ahead and find it like by doing algebra here. So this is the sum of the first 15 terms is equal to 7.5 times 4 plus, I think it's 42. Yeah, 42. So order of operations, that's 7.5 times 4.4. No, not 4.4, 44. What am I doing? 44. I don't know why I thought it was 4.4. Which means that the 15th term, sum of the first 15 terms is 345. So in theory, you don't need this formula to do this. If I said you have to figure this problem out and you didn't know about this formula until today, you could figure it out, right? You would just keep going with the common difference, and then you would have to take the sum of the first 15 terms. But I think it would take you a lot longer than this, right? Yeah. Yeah, you're right. The answer is, thank you. I don't know what I was doing there. But the answer really is really 345. That was calculated earlier. Thank you. Sorry about that. Yes.